Whoa, that was loud. Okay, so definitely new stuff today. Natural logs, which I don't know, seems like nature logs, like outside trees. That's not what we're talking about, but that's what I think of when I see that. Natural logs and E. I guess let's start with E. Have any of y'all seen that number before? Maybe you've just seen it on the calculator. What is that? Where did that come from? No, that's like double E is times 10 to the, so it's not that. There it is on the calculator. E to the x, and there it is just by itself over there. Second E. 2.718281828. But it doesn't end there. It's kind of like pi. It's irrational. It goes forever. 2.718281828, and who knows? We don't need to memorize that number. It's kind of like pi. Like 3.14 is good enough, or just hit the pi button in the calculator. Same thing with E. Like you probably need to know that it's 2.718. I don't know, that seems weird. We always math people use 3 decimals for E, but 2 for pi, whatever. So you need to know that, and then you need to know or understand that that's not that's not exact. That's rounded. What the heck? Where it comes from it's kind of a calculus thing. So I'd say you don't even have to write this down, but 1 plus 1 over n to the n. If you plug in a really big number, you get E. So 1 over n starts getting small, but n starts getting big. Let's try 1 plus 1 over 500 to the 500th. Yep, we're getting close to it. So if n gets really, really big, that's the official definition of E. You don't need to know that. That's just a little side note. It's kind of a calculus thing. So it feels a little out of order that we're using a number that comes from calculus, but we're not in calculus. So that's why we kind of just say, oh, E is this magic number, and don't worry about where it comes from. But it fits in here because a lot of times we want to use log base E of something. Log base E of x. Log of x, yes. But the E is lower, right? It's not the word log. It's log base E of x. And here's the deal: is this number happens a lot in nature, hence the natural log thing. As weird as that expression is for E, that number is naturally occurring in nature things frequently. And so what we frequently want to do is use log base E. And because we use it so often, it's another place where mathematicians are like, I don't want to keep writing log base E. Let's just call it natural log. So natural log is log base E. That's the same thing. So that's an ln, natural log of x. Means exactly the same thing as log base E. So you'll never see this written because that's kind of dumb. We've decided we'd rather use natural log. But that's what it means. So natural log is base E. A little reminder, what is log of x if there's no base there?
Base 10.
That's base 10. So be careful. Log without a base is base 10. Natural log is base E. All right, let's try a few. Natural log of E squared. And again, you can think about the fishhook thing still works. It's just that's a base E. So think about the fishhook. So I need e to some power to equal e squared. 2. Like, what? That's not really that hard. You're like, yeah, that's right. It shouldn't be. How about natural log of 1? 0. I'm not drawing the fishhook, but mentally I'm thinking about the fishhook. What natural log of 1 means is e to some power equals 1. Well, that's got to be 0. E to the 0 is 1. Natural log of the square root of e. Again, the fishhook, e to what power is the square root? Well, square root's the same thing as 1/2, so e to the 1/2 equals e to the 1/2. Natural log of 1 over e cubed. -3. Again, I'm not drawing the fishhook anymore, but mentally I'm thinking about it. E to the what equals 1 over e cubed. Well, e to the -3 would make that work. And then what should be the easiest one of all, but sometimes messes people up, I don't really know why. Natural log of e, 1, because e to the first is e. So you're still just fish hooking today, but we've added this idea of a natural log means base e. I would say rather than fish hooking these every time, it would be helpful if you just knew these. These happen frequently, and you don't have to memorize them because you can figure them out. But if you have in your brain that natural log of 1 is 0 and natural log of e is 1, that makes things go a little quicker than having to think through the fishhook. So that's a little side note. I'm boxing it, but I'm not like super starring it because you don't have to memorize that. You can figure it out every time. Just those happen more often than any other. And so, or maybe it's just so that you use it so often you end up memorizing them, so that when you see them in pre-cal and calculus, you don't mess them up. Now, let's do some examples together off of the worksheet. Seis de Mayo today. So that next worksheet is Tuesday, 5/6. Part 1, Part 2, Part all of them, yes. It looks like a lot, but they're going to go really quick. Simplify each expression, no calculator. By the way, the test, the 2-part test next week, Part 1 is no calculator. Part 1 is no calculator, Part 2 is with calculator. So you'll be able to figure out what's on each part of the test. Let's, I guess, just start with number 1. Simplify each expression. Don't have a calculator, so I can't just type it in and give a number. But what's e to the 4th times e to the 5th? E to the 9th. Right? The exponent rules still work. How about e over 3 to the -2? 9 over e squared. Right? Flip it and square it. So I feel like those are pretty easy. You guys are blitzing through them right now, as you should. In fact, let's do a few of the next line, and then I'll pause for a second and let you work on them. How about number 14? Evaluate that without a calculator. 4 natural log of e to the -3.
13, my bad.
Number 13, sorry. It's like 0, where'd that come from?
14.
So number 13. What's number 13? So e to something equals e to the -3. That's -3. So that answer is -12. Let me show you a slightly different way to work number 13 that uses properties and uses a couple of properties. Where else could that -3 go? could go in front as a coefficient. So now I've got 4 times negative 3 times the natural log of e. The natural log of e is 1, so that's just negative 12. So slightly different ways to get there on number 13. All right, take a couple minutes and do 1 through 16. I'll hit 16. Okay, number 17 through 26. Expand. Okay, so we've expanded before. We're still expanding. The rules are still the same, except instead of base 2 or base 5 or base 7, it's base e. And so they work the same way. So let's look at number 18. Let's see, I've got 5 times x cubed. So what could I do to split apart the 5 and the x cubed? I could add them. So natural log 5 plus natural log x cubed. That's still not expanded all the way. There's one more thing we could do. Put the 3 in front. But be careful, if you back up, that means you couldn't have taken the 3 out front first, because the 3 was not on the 5 and the x. The 3 was only on the x. So when we end up splitting it up, it makes sense that the 3 is only on the x stuff. Yeah, I was going to say just.
How do you multiply them but have the negative?
So 19. Okay, there's a couple ways to handle 19. Do you want to split it up first, or do you want to move that y cubed to the bottom first? It's not going to matter, is the short answer. Let's say we split it up first. So that would be natural log x to the 4th plus, because they're being multiplied, natural log y to the negative 3. Now we can put those exponents out front. So 4 natural log x minus 3 natural log y.
So wouldn't that make it divided? Oh, but I guess you flipped it, okay.
So if you had written it like this first, then you still would have landed there. So another one of those where there's slightly different paths, but you should end up at the same spot. So that's a good one, because you're like, ooh, what should I do first? And the answer is, it doesn't matter. You can split it up first, or you could move that y cubed to the bottom and then split it up. But yeah, either way, we end up with a minus 3 natural log y. Which one? 21? When you say multiply them by 1/2, you might be right. I'm not sure. Like, do you want this? Do you want this? Yeah, that's a power of 1/2. So that 1/2 can come down front and give us this. So keep doing what you're doing. Work through 26. Bottom part, so it's going to be minus. I'm going to do, like, I could distribute the minus, or I could put it in parentheses. It looks like most of you are going with parentheses, so that's fine. Natural log of x plus the natural log. I don't know how to clarify which natural log is what, but the natural log of the natural log. To indicate where those pieces came from. That's weird, the natural log of the natural log of x, but that's correct. And you could distribute the minus sign, or you could leave it in parentheses, either way. Questions on any of the others through 26? That's weird, but have it back. And another page after that. Oh my gosh. Are we gonna survive?
Mr. Wolf, are there graphs?
Well, those are tomorrow, so just, one day at a time. 27 through 34, use the properties to condense. So it's sort of the same process, but in reverse, right? So now they're spread out, now we want to squish them into one. So is there one you want me to work to? I don't know. You probably don't even need me to demonstrate. But I had 32 circled, so I'll do 32. Let's see. 32 is not the best choice because they're all positive, but 4x cubed square root of y. Man, when you get good at these, they go quick. So take a few minutes to try through 34. I can clean that up. I don't need a calculator. 6 to the 4th, that's like 3 to the 4th times 2 to the 4th. No, not 81. I mean, yes, it is 81, but I don't want to do that. I did that so that I could reduce right here. And then 25 squared, we've done this trick before. Another way to write 25 is 5 squared. So that's 5 to the 4th. And now I've got some simplifying I can do that makes that a little bit easier. So 3 in the top, 2 to the 4th in the bottom, and 5 squared in the top. Yeah, I don't need no stinking calculator. 25 times 3 is 75. 2 to the 4th is 16. Look at that. Look at us go, showing off our math. All right, what I really wanted to get to, and what we'll need to work on now, is this with calculator. Now, maybe you're thinking with calculator is easy, and I guess it is, as long as you know how to use the calculator. 35, e cubed. Well, your calculator, or at least these calculators, have 2 different buttons for e. E almost always comes with an exponent. You can see that as, like, e is almost always an exponent. So they built the calculators with that in mind. So instead of having to do e raised to the, like you could do that on the right-hand side, they have that button built in. So second natural log automatically gives you an e with a power. So because that's usually how we use it, they made that a built-in button to save you some time, because it just takes so long to hit that caret button to go up to make a power. So that's all we're doing, is typing that into the calculator and getting 3 decimal places, so 20.086.
Is this the pile of dead calculator?
Well, it might be a pile of calculators on their last legs. That one's just dead. Yeah.
This one turns on for like a second.
So that first set there, that's pretty easy. Like, you're just typing things into the calculator, making sure you know where the buttons are, and giving an answer to 3 decimals. So let's pass on that. I want to make sure we hit some of everything before we go. Let's skip down to 46. So it's with calculator, but before I grab the calculator, I need to get x by itself. Here's extended directions. Algebra first, then grab the calculator. Students think that if they have a calculator, they immediately want to start punching things in. You're like, no. Do the math first, do the algebra first, then grab a calculator. When I say do the math first on 46, what do you think we should do first? Okay, get x by itself. What could I do to get x by itself? do the fishhook thing. E to the first equals x minus 6. And now that's an easy problem. I just add 6 to both sides. E plus 6 is what we would call an exact answer, because it's perfectly correct. But this one asked for nearest thousandths, so E plus 6, 8.718. That would be the rounded answer, and that's what it wants. It's the rounded answer. So on that section, you're going to have to do a little bit of fish hooking first, maybe some combining first, and then fish hooking, looking at 49 and 50. Solve, and then the last step is the calculator. So don't grab the calculator first. Do the math first, then grab the calculator at the end. In fact, why don't we do 50? What should we do first on number 50? Combine. So what do I get when I combine 5x and x? Good. 5x squared. Then I can fish hook, so e to the 7th. That's weird, but I have a calculator. Equals 5x squared. Divide by 5. Good. We're not grabbing the calculator yet. Like, I don't really care what e to the 7th is. That I don't want to carry around that weird number. So let's divide by 5 first. So e to the 7th over 5. And then, again, I don't really care what e to the 7th over 5 is, because what else do I need to do? Take the square root. And when I take the square root, I need to think about plus or minus. Although, when I look back in here, if I tried a negative, that wouldn't work. So this would be a spot where if you forgot the minus sign, you'd still be okay. Okay, so I need to square root e to the 7th divided by 5. Weird number, but that's fine. We got a calculator. 14.810. And with a calculator, these are easy to check. So if you were really worried, you could plug 14.810 back in the beginning and hopefully get 7, or really close to 7, because we rounded that. Okay, turn the page. There's only 1, 2, 3 more on the last page. How hard can it be, right? Interest rates compounded continuously. Okay, it's a separate formula for continuously compounded interest. Like before we had, what was it, a times b to the x. So it's going to look a little bit like that, but there's going to be an e involved. There's our new formula for the day. P times e to the RT. P is called the principal, but it's better just to think of it as the pre. P is the pre. The before you start investing, how much money do you have? It's the initial amount. A officially stands for amount, but I feel like that doesn't help because there's a before amount and an after amount. So I think of A as standing for after. So the pre and the after. And then R is the rate and T is the time. So let's do 51 together. Horatio opens a bank account that pays 2.3%, 0.023, annual interest compounded continuously. He makes an initial deposit, so there's my P, $10,000. What will the balance of the account be in 10 years? So 10,000 e to the 0.023 times 10. And obviously you have a calculator. 10,000. Again, the e to the button is handy, saves you a little bit of time. 0.023 times 10. So in 10 years, he's got $12,586. A gain of $2,000 after 10 years. Not great, but he was only getting 2.3%. So, that's what you get with a bank. All right, 52, 53 are pretty similar, and we're almost out of time. But hey, we did a whole bunch of that worksheet together, so tomorrow we'll get to graph, Cooper, so that'll be exciting.